Hello guys, good afternoon. Hi. So hope everyone is doing great. Hi guys. Hello. Yeah, hope everyone is doing great. We are meeting after 2 days of gap. After one long, short weekend. Yeah, it's the short weekend, right? So, how's your weekend, guys? How's your weekend? Good afternoon, all. Hi. So hope you guys are having good time. And yeah, so what's happening here is we are in Gen Hassan and taking online class. So in today's class we'll be studying about electrostatics, the electric field. In previous class we had learned about electric fields and stuff. So yeah, guys, for confirmation I'll be starting with a technical check. Please let me know if my voice is clear to you guys and my board is visible clearly. So if there is any issue with my voice or voice modulation or any other things, please let me know. Okay. Hope. This is good. Hi. So hi guys, hi everyone, the YouTubers. Hi Hari Prasad. I'm doing good, Hari Prasad. Hope my screen is visible to you guys too. Let me know if my screen is not visible under all circumstances. Yep. Yes. Then guys, yeah, today we'll be doing some, we have some syllabus pending, like the theory part. So we have to study a small part of theory, a small tiny bit. Then after that we'll be starting with problem solving. So we have some set of problems for both electrostatics of the Coulomb's law. The syllabus of problem solving includes Coulomb law and also electric fields. Okay, so we'll solve problems on both. Okay, so I hope everyone is able to hear me clearly and my blackboard is visible. So I'm going to end the poll. Yes. So yeah, we started with something called as electrostatics. So we'll have a quick revision of what we had studied so far. So we had started something called as electrostatics, where electrostatics means study of charges which are at rest, right? It's the study of charges which are at rest. Now, yes. So what about it is study of charges which are at rest. Hi, good afternoon. Good afternoon. Yeah. Next thing which we studied was properties of charges. What are the different properties? So what are different properties, guys? Properties are like poles repel, unlike poles attract. Like charges repel and like charges attract. And again, we had quantization and conservation. Charges. Then we studied about modes of charge transfer. What are different modes of charge transfer, guys? Tell me. Modes of charge transfer. What were the different types of modes of charge transfer? Yes. Conduction, friction, yes, and induction. So guys, try to inform all your classmates, all your friends that we have class right now. Let them attend. So there is very less number of students attending the class right now. Inform them if they have, in case missed the class, or if they don't have the information about the class, let them know. Even the YouTubers, please try to inform your friends so that they could come attend the class, guys. Yep. So next we learned about Coulomb's law. So why is Coulomb's law used? So Coulomb's law gives the force between the electrostatic force between 2 point charges. So we learned F is equal to K times Q1 Q2 divided by R square, and where K was 1 by 4 pi epsilon naught, where epsilon naught was absolute permittivity. Yes. Yo, bro. Yes, again, guys. Yeah. Yes. Then we learned about modes. Okay. Multiple charges. Coulomb's law applied for multiple charges. So we used vector addition for that, right? Vector addition. So then, yeah. So then we started with electric field. Okay, sorry. Then we started with electric field. What is electric field? What is electric field? So electric field was given by E is equals to force upon charge. Yes, force per unit charge was given as electric field, or force F is equals to Q times of E. Then in our previous class, we learned that how to draw electric field. How to draw electric, not electric field, it was electric field lines. So guys, reply in the chat box, what were the steps to draw electric field lines? What is the first rule? Rules. Tell me the rules. What was the first rule? What was the first rule, guys? Students in YouTube, please try to respond. Hi, guys. Hi. So hope you guys are doing well. And guys, try to respond so that, yeah, yes. So that it gives me energy to do the class. Yes, correct. So we start the electric field lines from positive charge and end at negative charge. Okay, so we start at a positive charge and end at a negative charge. Second rule was the electric field lines never cross each other. Then what was the third rule? Third rule, the electric field lines are, yes, correct Namrata, Prajwal, correct Prajwal, correct Dikshita. Yeah, electric field lines are continuous in a which region? In a charge free region. In a charge free region, my electric field is continuous. What was the last rule? The last rule says the electric field lines never form closed loops. So these were the rules which we used to draw the electric field lines. Yes, we use electric field lines, one, to find the direction, two, to find the strength, right? So use the electric field lines to give the direction and the strength, and the tangent drawn to this electric field line gives me the direction of electric field, and gaps or density of electric field line gives me the strength. So this is what we learned in our previous class. In today's class, we'll be starting with drawing electric field lines for multiple charges. Okay, guys. So I have set of rules here. I have a positive 2 coulomb charge and a negative 1 coulomb charge. So I want you guys to draw the electric field for this. Guys, come on. Everyone try to draw the electric field lines for this. Come on, guys. Yes, YouTubers, come on. So what are steps to draw, guys? What are the steps to draw electric field lines for multiple charges? So the steps are same. Electric field lines start at positive charge and at negative charge. The electric field lines never cross each other. Electric field lines are continuous in a charge-free region, and electric field lines never form closed loops. So what do we have here? We have a plus 2 coulomb charge, and yes, come on, guys. So I'll draw and minus 1 coulomb charge. Okay, now I want to draw electric field lines for this. So I know whenever I want to draw my electric field lines, I'll draw the rising sun, right? Yes. Now guys, again here, even here. So my electric field lines are like this. Now what is the change I have to make to draw the electric field lines? Come on, tell me. Come on, tell me, guys. So what should I do? The change in +2 coulomb charge. So all the rays, all the yes, arrow are always away from the +2 coulomb charge. Yes, arrow is always, first rule thing is arrow is always away from +2 coulomb charge. And for -1 coulomb is arrows are always towards, right? Yes, inwards. Now the electric field lines start at positive charge and end at negative charge. So they start at a positive charge. Let me end these electric field lines in a negative charge. Okay, I'll erase this. Right? So this is how we could draw the electric field lines for this. So one other okay, more of these go out to the infinity level, and some of these come from infinity and try to join this 1 coulomb charge, right? This is how we draw the electric field lines for two charges, multiple charges, when they are in a charge free region. Okay, if you have got this, have you got this, guys? Have you understood this? Yes. Cool. Then try this. Now try this. Everyone try this. Okay. So I have a +1 coulomb charge and a -2 coulomb charge. Okay, what are the things I should do? Again. So the +1 coulomb charge would be having 1, 2, 3 and 4. Say I have 4, and -2 coulomb charge would be having 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, now yes, we have drawn the rising sun. Now okay, I have drawn for positive charge. For negative charge it's always inwards. Okay, it's always inwards. And few of the lines, okay, I'll join these two lines, I'll join these two lines, and I'll join these two lines. So rest all are coming from different regions. Okay, yeah, this is how we draw the electric field lines for this. Got it? Yeah, this you know, right? So let's move on. Let's move on. Okay, shall we move on? This is understood, right? I hope by now everyone are clear how to draw electric field lines for multiple charges too. Yes. Cool, guys. Then last one. So I have a +1 coulomb charge and a -1 coulomb charge. What is this called as? If I have two charges of different signs but same magnitude, what is this called as? What is this called as? Hello guys, come on. Yes, these are the dipoles. We will study about dipoles in detail in our next part of the class. Okay, again we'll quickly draw the electric field lines for this. So these are always outwards and these are always inwards. Okay, yeah, so these electric field lines come here, and I guess this comes here and this comes here. So this is how we draw the electric field lines for dipoles. Cool. Yes, understood guys? Yes. Let me draw a smooth curve. Actually it's a smooth curve. Yep. Okay guys, then if you have understood that, try to answer this question. So the first question goes like, the electric field at A due to charge Q is E. So again, I think we solved a similar question some time ago. So the electric field at A due to charge Q is E. So I have a charge Q here. So what's being asked? So I have a charge Q here. Now because of this charge Q at point A, my electric field is E. Okay, another charge plus Q is introduced. Now this is first situation. Okay, these are two different situations. First situation. Now in second situation, what happens? I introduce a new charge Q. Positive Q is introduced. Capital Q is introduced near A. the electric field line at A due to charge Q is, so what is the electric field? What is the electric field at A due to Q? Option A remains same, option B increases, option C decreases, option D can't say. Hi guys, so people at YouTube could also reply. Please try to reply, guys. Yes, come on guys, come on, come on. Yep. Cool, 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 guys. Awesome. So it's very warm today. Yeah. So how's climate at your end? Hope that's great. So I see most of you are here from Hyderabad region and some from Shillong region too. So I see that Shillong region had a very good climate over there. Is it? So YouTubers should be knowing. So yep. Dhanush, check your answer, please. Check your answer. Check your answer. Okay, guys. So it's 25 seconds. I mean, 25 people have answered. It's 1 minute up and counting. So I'm going to end the poll now. So most of you say option A. Yes. See, I think we had discussed some similar question some time ago, guys. So say I have a charge. So the example goes like this. I have a charge Q. Now, because of charge Q at point A, say I have a point A here. Now, because of charge Q at point A, I have electric field E. Now, what I do, I have introduced a new electric field, I mean a new charge. I introduced a new charge Q here. Now, this Q is nearer to A. The electric field due to Q, small q, the electric field due to small q, does it change, guys? Does the electric field due to small q change? Reply your answer, please. No. The electric field due to charge q, even at this point, the electric field remains the same. Even at this point, due to charge q, small q alone remains the same. So option answer is option A. Yes, remains the same. It's the correct answer. Okay. Cool. Yes, guys, got this? Got this? Yes. Okay. So I have a question for you guys next. So let's move on to next topic. Okay. Yes, Prakash Koda, you have sent no. I hope. Okay. Is there anyone who did not understand this question, guys? Please click on yes or no. If you have understood, click on yes. If you have not understood, click on no. YouTubers, you could reply me in the chat if you have understood this. Okay, no. Okay, cool. So I'm going to explain this again. See, listen carefully. So what's happening here is, see, initially I have a charge Q. Just a moment. Yeah. Initially I have a charge Q. Now because of this charge Q, I have some electric field. Okay. Because of this charge Q, I have some electric field in all directions, right? And what should be the magnitude of this electric field? What could be the magnitude of this electric field? Reply. What could be the magnitude of this electric field? Yes, it is. Say let us consider, okay, it's given here. The electric field due to charge Q is A. Sorry, electric field at A due to charge Q is E. So E is the electric field due to charge Q at point A. Now, what I'll do, near point A, I'll bring another point charge. Whose magnitude is Q, capital Q, near A. The electric field at A due to charge Q. Now, because of charge Q, what is the magnitude of electric field now? So because of charge Q, what is the magnitude of electric field at point A is my question. So does that change anything? So bringing another charge at Q, does it change the magnitude of electric field at A? Yes, it may change, but what is the magnitude of electric field from Q? They are asking magnitude of electric field due to charge Q. Due to charge Q is very important here. Only because of charge Q. Only because of charge Q. I mean, what? So only because of charge Q, what is the electric field at A? Even after introducing a new charge, what would be the electric field at A because of small q? Because of the charge small q. It still remains the same, right? There will be no change, correct Tejas? There will be no change at all. So initially it was E, say here, initially it was E. Electric field, it was E due to charge Q. Initially it was E at A. Even now at charge at point A, the electric field is E, irrespective of I bring this or not. Irrespective of this, the electric field due to charge Q is E at A. Okay. Okay. I have a question for you guys. So, what is this? What do you see here? What do you see here? So we have an aeroplane. How many of you have traveled in aeroplane so far, guys? So how many of you have tried to travel, or how many of you have traveled in aeroplane so far? Okay, how was your experience? Did you ever try? So some people are telling yes. Okay. Okay, no. Okay, fine. So whoever tried, I've traveled in aeroplane. Have you ever experienced thunderbolt strikes? What do you think could happen? What do you think could happen when a thunderbolt strikes the aeroplane? What do you think could happen? Acha. Think. I need answers. Guys. Come on. I need answers. What happens when the thunderbolt strikes an aeroplane? What would happen? Okay, it won't strike. Acha. So some people are telling it won't strike. Okay. So okay, what would happen to the aircraft? Acha. What would happen to the aircraft, or what would happen to the people inside the aircraft? What would happen to the aeroplane, or what would happen to the people inside the aeroplane? Nothing. Why? Why is it nothing? Something should happen, right? Okay, if I'm standing here, and if I get an lightning, what would happen to me? Say I'm in my position. If I get a shock, if I get a thunderbolt hit on me, what would happen? Yes, correct, Amit. So similarly, I have another question. Yes, correct, Danush. Okay, similarly, I have another question. How lightning striking car works? So I hope if many people have not traveled in aeroplane, at least most of at least most of you would have traveled in a car or a bus or any vehicle for that reason. For that reason, any vehicles. So what happens? Yeah, when you're traveling in a car, suddenly some lightning bolt strikes your car. What happens to you? What happens to the people inside the car? So there are some people inside the car. What happens to them? Acha, correct, Midun, Danush. Nothing. Why? Why nothing? So yeah, nothing happens to them. Why? So is it because my tires are made of? Is it because my tires are made of rubber? No. Then why? Why do you think? Why do you think I won't get a shock, or I won't get a shock? Yeah, I won't get shock, or I won't get electrocuted when lightning strikes me. So we'll try to answer this. Acha, car is hollow conductor. Cool. So we'll try to answer this with this experiment, with this explanation. Okay. Okay, I will try to answer this. Okay, so let's learn about something called as electric field inside a conductor. So when we bring an electric field, so consider a conductor. Say I have a conductor. What's a conductor, guys? What's a conductor? Come on, guys. Tell me, what's a conductor? What's a conductor? Anything which conducts electricity, right? Okay, anything which conducts electricity is a conductor. So why does conductor conducts electricity? Why does conductor conduct electricity? Yes, which allow free flow of current. Correct, Chinmay. So why does that happen? Yes, because of free electrons. Say a conductor is consisting of large number of free electrons in it. Say, okay, now let us consider such conductor here. So we have a conductor here which has free electrons in this conductor. Now, what happens if I bring a charge? So what I'll do, I'll bring a charge to this. Now, if you bring a charge near it, observe this, observe this. What happens if I bring a positive charge near the conductor? Reply, guys. What happens? What could happen if I bring a positive charge near my conductor? Say, in my conductor, say if this is a conductor, the total number of positive and charges are equal in a neutral conductor, right? So if I have a conductor, I have total number of positive and negative charges are equal. Now what I'm doing, I'm bringing a positive charge. I'm bringing a positive charge near the conductor. What would happen? Guys, are you here listening? Try to answer, please. Keep up the spirit. Keep the spirit up. So, yes, correct, Prajwal, correct. So, when we bring a positive charge near the conductor, what would happen? Okay, give me a vague idea, general idea. Yes, positive charges move away. Why? Why? Yes. Chandrika says, I think all negative charges will attract and all positive charges. Mithun says, all positive charges will move away. Yes, this is exactly what happens. So, now when we bring a positive charge near a conductor, neutral conductor, what happens is, all the negative charges are accumulated on one end near the positive charge. So, there are these electrons, right? These electrons are getting attracted towards the positive charge, and all the positive charges are repelled away to the other side. See, all the positive charges are repelled away, all the negative charges are attracted towards. Now what happens? This creates, because of this external electric field, because of this external electric field, this creates an internal electric field inside the conductor. What happens? There will be a creation of internal electric field inside the conductor. This internal electric field, as charge comes closer and closer, this internal electric field also builds up such that at one point my external electric field and internal electric field will be equal. At one point my external electric field and internal electric field will be exactly equal. At this condition, what happens is I get, okay, okay. At this condition, I get my E external and E internal are equal. At this condition, what happens? So, my external electric field and internal electric field, my E external, the external electric field is equals to E internal, the internal electric field formed. So, what happens? Since both are equal, when we add E external and E internal, I get the net electric field inside a conductor. The net electric field inside a conductor is 0. This is E net. This is my E net. Net electric field inside a conductor is always 0. So guys, hope you understood this. So whenever we have an electric field or whenever we have some electric charges near the conductor, so it forms its own internal electric field due to the imposition, okay, due to the induction effect of external electric field. The electric field in the inside a conductor, there will be a formation of internal electric field, and this internal electric field will be of equal magnitude at one point. At a point, At a point, my external electric field will be equals to my internal electric field. So E external will be equals to E internal. Then the net electric field will be equals to 0. This is the reason why we don't feel, I mean, the electric field inside a conductor is 0. So where do we apply this? Okay, did you understand? Do you guys understand this much? Yes. So what happens when we have external electric field brought near a conductor, neutral conductor? Yes. Click on us if you have understood this. Okay, no. Okay, so yeah, going again. So listen carefully. I have a neutral conductor. Okay, we consider a neutral conductor. Now what happens? I'll bring a positive charge. I'll bring a positive charge. Now what happens when I bring a positive charge? So these positive charges, this positive charge exerts electric field in this direction, right? This positive charge exerts electric field, positive electric field in this direction. Now what happens? Because of this positive charge, all the positive charges which are present in this location are repelled away. See, you could see here, all the positive charges are repelled away and all the electrons are formed on near the surface. So in the presence of external electric field, a positive external electric field, what happens is all the positive charges are repelled away. So all the positive charges are repelled away, all the negative charges are attracted towards one end. Now what happens after some time? Yes, the external electric field, okay, there exists an internal electric field now. Because of this external electric field, there is difference. Like what happens inside the inside the conductor? All the positive charges are at one end, all the negative charges are at the other end. Now what happens? This creates an internal electric field. So this internal electric field is from positive of, see, we know that electric field starts from positive charge and ends at negative charge, right? Here, there is only positive charge, so it's moving outwards. So this is my external electric field. Now, because of this external electric field, what is happening? The positive charges are thrown away towards one end, all the negative charges are put at the other end. Now all the positive charges which are at one end creates an internal electric field towards negative charges. So there is a creation of or inducing of internal electric field. So there is an inducing of internal electric field. This electric field is when what happens, this electric field, when the internal electric field created or induced, the internal electric field which is induced becomes equal to the magnitude of external electric field. What happens? It will, the net electric field inside the conductor, the net electric field inside the conductor will become 0. What happens when the the external electric field E external is equals to E internal? So E external and E internal are equal. At this point, what happens? The net electric field, if I want to calculate my E net, I should add them, right? So E external was in this direction, E internal was in this direction, right? So these two are of same magnitude in different opposite direction. Same magnitude in opposite direction. Now what happens when I add them? They add up to become 0. The net electric field inside a conductor will become 0. Hope everyone have understood by now. Yes. Guys, reply if you have understood. Yes, no, something. Yes, cool, guys. Thank you. Yeah. Now can you, now can you explain why, so my net electric field is 0. Now can you explain why we don't get electrocuted in a plane? So you could see in the GIF, I mean in the image in the left side, what's happening? In the image which is in the left side, what's happening? There is an aeroplane. So there is an aeroplane which is moving with some speed and lightning is striking it. But what's happening? So if you see here, Here, the aeroplane consists of three layers. Okay, the aeroplane consists of three layers. One layer of copper sheet. There is one layer of copper sheet, one layer of silicon rubber, and one layer of resistive sheet. So what happens? This copper sheet is a pure conductor. It will form the electrostatic shielding or electric shielding. What is electric shielding? What happens whenever lightning strikes it? Yes, it's more like an electric field, the external electric field. The metal which is present here, the copper, will create an internal electric field, and it will neutralize. The net electric field will be zero. And what happens? This electric charge, which is being the lightning, will be discharged to ground again. So there is an so back then they were using copper sheets, but that added weight to the aeroplane. So in today's world, in modern world, they use aluminum sheets. They use the aluminum sheets, so it will be like a mesh. Okay, that will prevent the airplane from lightnings. Okay, that's how they won't get any charge. I mean, they won't get any effect of lightning. The passengers won't get. Okay. Similarly, say there is something called as Faraday Shield. How many of you have watched this movie Vishwarupam? If you remember, in Vishwarupam and one more English movie also had this. So how many of you know this Faraday Shield? Yes, guys. Faraday Shield. So there is something called as Faraday Shield. Well, it's nothing but a cage. Actually, it's also called as the Faraday's cage. I'll change. A Faraday's cage. So what happens here is it's similar to any other cage. Okay, it's similar to any other cage, but this is having a very tiny space. Like, okay, it's more like a thin sheet. Say it's more like a mesh. You know what's a mesh? You know the mosquito mesh which we use, right? So it's of this small thickness, means the small orifice there, and these conducts whenever we, this is Tesla coil which is passing high voltage of thunderbolt like shock, I mean electric discharge. This is the Tesla coil which is discharging high voltage. Now this person can touch that, but I mean can feel that, but he won't get any shock. So this is a Faraday cage. This Faraday cage is used in many applications, say for the military purposes. Military purposes, they don't want their secret information to leak out, right? So whatever the communication they do inside a cage where there is no interference of any other magnetic signals or EM waves. There won't be any interference. Okay, you know what is this, guys? You know what is this? What is this? You know this? This is the microwave oven. So there, even the microwave oven consists of, if you see, the microwave oven also consists of small, tiny mesh-like structures. Okay, the microwave also consists of small, tiny mesh-like structures. So what's happening there? These meshes prevent the electromagnetic radiation from exposing out. So these mesh, what they will do, they absorb all the radiations which are harmful for human beings, but they just help in cooking the food. These rays should not interfere with human cells, right? If they interfere with living tissue, it will boil them, it will burn it, right? So we don't want that to happen. So we use the Faraday shield even in microwave. And again, yeah, even your car, it's not the rubber tires which is preventing you, it's the electrostatic shielding which is due to the electric field, electrostatic shielding effect of conductor, which is protecting you. So whenever there's lightning, don't come out of your car. Okay, that's better. So don't step out, stay inside your car, stay safe. Okay, got this? Yes, guys, shall we move on? Yes. Hi, YouTubers. I see no response from you guys. I try to respond. Thank you. Okay, guys. So if you have understood this, I have a question for you guys. So the concept test. So we have a conducting slab. So what do we have? We have a conducting slab. Say we have a slab which is conducting in an area with no electric field. At t is equal to 0. Okay, there is no electric field for this conducting slab. Okay, I have a conducting slab here. At t is equal to 0, a uniform electric field is applied. So after some time at t is equal to 0, uniform electric field E, say I'll name this E, is applied in that area. The electric field inside this conductor is 0 at every instant of time. Is it true? False? Depends on the angle? Cannot be determined. What's your answer? If you have understood this, try to answer. So we have a conducting slab which is placed. Now we have some electric field which is being incident on that electric slab. Now the question is at t is equal to 0, when we apply the uniform electric field, the electric field inside the conductor is 0. Is it 0 at every instant of time? Okay. Come on guys, tell me. Should take less than 30 seconds. Is my voice unclear, guys? Is my voice having any issue? I know there is some issue with my laptop, I guess. Again, yeah. Is there any issue with my voice? Please, somebody confirm. Okay, no, no. Thank you for confirmation. Cool. So, guys, yes. Take a stretch break. Yeah, cool. Sometime voice is breaking. Cool. Okay. Okay, I'll try to keep my voice in a good mood. I mean, there is some disturbance here, slow network and stuff. So we'll try to rectify that. Yeah. So I'm going to end the poll. So out of 49, there are only 32 students who are active. Why? I want more students to actively participate. So guys, if I say most of you are wrong, if I say most of you are wrong, actually, yeah, let's check the answer. So the answer is B, false. Acha, why sir? Sir, you said electric field. Yeah, when electric field is applied to a conductor, there is no electric field inside the conductor. The net electric field inside the conductor is 0. Then now you are telling it's false. Why? So I have highlighted the question. So is it at every instant of time? Is it at every instant of time is the question. Yes. Is it for every instant of time? The electric field inside the conductor is 0. Is it at every instant of time? No. If you remember what happened? Yeah. Initially, when I have my conductor, so when there was some external electric field, there was all the negative charges come at one end, all the positive charges went to other end, and there was an internal electric field. But this internal electric field was not exactly equal to external electric field at initial case. At initial instant, initially internal electric field E internal was not equal to E external. Okay, E internal was not equal to E external. Now what happened after some time? Say what happened when more number of electric field lines came. After some time, the internal electric field was equals to external electric field. Then we got our net electric field inside the conductor to be 0. Yes. Got this? Yes, guys, come on. Click on yes if you have understood this. Yes, yes. Cool. So this was the very small part which I wanted to cover. So the time now is 3:43 p.m. So we'll start with question solving. So what we do is, guys, I'll display the question. I'll give you 1 minute of time. So if the question is too difficult, I'll give you 3 minutes of time. If the question is simple, I'll give you 1 minute of time. Okay. Okay. Click on yes. Yeah, understood. Okay, we'll solve all the questions today. Okay, come on. Ivamonos. Start. So two equal charges are placed at a separation of 1 meter. What should be the magnitude of charges so that the force between them is equal to a weight of a 50 kg person? So what happens, what's given here is I have a 50 kg person, 50 kg person. Now I have two equal charges. Say I'll call the charges as Q and Q, and their separation is 1 meter. What should be the force? I mean, what should be the charge? What is the value of Q? What is the value of Q if if the force is equals to weight of a person? So try to answer this. I'm giving you 1 minute of time. Your time starts now. Come on, guys, try this. Try this. So, what is the how to approach this? Come on, tell me. YouTubers, please try to answer how to approach this question. So, I have a 50 kg person. Now, I want to calculate the magnitude of charge of two charges. I have to calculate the electrostatic force. Which law should I apply? Which law should I apply, guys? Yeah, we should apply the Coulomb's law, right? We should apply the Coulomb's law. Okay, let's check. So we should apply the Coulomb's law, and we should find this force should be equal to the weight of a 50 kg person. Now, what is the force experienced by a 50 kg person? Yes, correct, Samrat. Correct, Samrat. So what is the force? First you have to find what is the magnitude of force. Magnitude of force is equals to what? Come on, guys, tell me in the chat box. So only one person gave me the answer so far. What should be the force? What should be the force first? How to calculate force, guys? If force is to be the weight, yes, correct, Tejas. I want more answers. Yes, correct, Mithun, correct, Namrata. So F is equals to M into G, where G is given as 9.8. Guys, note this. G is not 10, it's 9.8. Yes, correct, Shashvita. Correct, Prajwal. Come on. What is the magnitude of force then? What is the magnitude of force? 50 into 9.8. It's equals to, yes, 50 kg into 9.8. How much is it? $50 kg into 9.8 is 490, right? It's 490 newtons. Now it's if it's 490 newtons, then try to calculate what's the energy. I mean, what's, sorry, excuse me. Yeah. What is the charge? What is the charge? Q. What is Q? What is the value of Q? So I'm going to erase this. What is the value of Q? Okay, guys, so I'm going to share your polls for you guys, and YouTubers, please try to answer in your chat box. Yes. So I started to receive some answers. Oh my god. Oh my god. Please take some time if you want some time, or if you want any mathematical calculations to be done, please ask me. Please ask me. If you want some mathematical calculation to be done, please ask me. I'll do for you. Yes. Don't mark wrong answers. So this is a very actually this is a level 1 question, guys. Come on, guys, you can do it. Come on, come on. So okay, have started receiving answers. Come on. Yes, come on, guys. Yep. Okay, so 1 minute's up. I'm going to end the poll and we'll try to solve the answers. Come on. So, yeah, I'll show you the poll results. The poll result is many of you have answered for C. Let's check the answer. Okay. Okay. So what's given to me? So I know the force Coulomb's law is given by F is equals to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. So I know the value of K. K is equals to 1 by 4 pi epsilon naught. This is nothing but 9 to 10 power 9 Newton meter square per Coulomb square. Now I know its magnitude. I will solve this. So I know the force. Force is 490 is equals to 9 into 10 power 9 into, since my charges Q1 and Q2 are of same magnitude, I'll take it as Q square by R is 1 meter. So 1 square 1. So what I'll get, Q square is equals to 490 by 9 into 10 power 9. So what I would get if I try to simplify this? Come on, guys, tell me what I would get. Try to simplify this. Try to simplify this. Try to simplify this. Yes, I would get 490. I'll put one more zero and take 10 power minus 1 by 9 into 10 power 9. So if I take just 10 power 9 up in the numerator, I'll get 10 power minus 9. So what would I get 4900 by 9. I'll get Q square is equals to, I'll write here, Q square is equals to 4900 divided by 9 into 10 power minus 10. So try to simplify this. 4900 square root of, yeah. So what would this be? This will be equals to Q2, or Q is equals to square root of 4900 by 9. So what is the square root of 4900 into 10 power minus 10, right? Okay. Uh-oh. There is an error. There is an error in the options given, guys. Guys, there is an error in the options given. So what happens is, yeah, square root of 4900 by 9 into 10 power minus 10, right? So even this 10 power minus 10 comes under the square root. So what happens? What happens? So try to give the answer, guys. Please try to give the answer in chat box. What should be the answer? I think these answers, these options might be wrong with the powers. Magnitude wise correct, but the power wise there is some mistake. There might be some mistake. Please try to calculate the answer and try to give me the answer, guys. in the chat box? Hi. Yes. So I should get, okay, I'll give you Q is 70 by 3 into 10 power. So square root of 10 power minus 10. How can I write this? Okay, we'll write here. Sorry for this. To 10 power 5, right? Minus 5. So 10 power 10. Yes. So 70 by 3. What would be the answer? 70 divided by 3. It's nothing but 2.23.3 into 10 power minus 5. If I try to simplify this will end up to be, okay, I'll use a different color. So Q will be equals to 233 into 10 power minus 6 coulomb, or Q is equals to 230 microcoulomb. Okay, guys. So yeah, answer would be 230 microcoulomb. So the option wise it's wrong. Sorry for this error. So it should be 230 microcoulomb. So there is 223.3 into 10 power minus 5. I'll divide and multiply by 10. So I'll get 230 plus into 10 power minus 6 coulombs. Okay. Prajwal, yes. Are you sure? Prajwal, please check your answer. Yes, guys. Any doubts, guys? Any doubts in this? Or you need do you need me to solve this again? Guys, let me know, please. Okay, understood. So answer is 230 microcoulomb. So my Q should be 230. Yes. Hope everyone have understood this. Click on yes if you have understood this, guys. Hi YouTubers, please reply. Hope you guys are replying, but I'm not getting any reply. Maybe it's because of my slow network. Okay, guys. So let's go to next question. If you guys have any doubts in the previous question, let me know. We'll discuss in the end. So next question, guys. So two particles of same material having mass of 5 gram. So I have two particles of same material having mass of 5 gram each. So both are having a mass of 5 gram, are kept, okay, and are kept on a table. Now these two are kept on a table having 5 gram weight and a of 10 power minus 7 coulomb, charge of 10 power minus 7 coulomb each. Now, since both are of same charge, what type of force are they exerting? What type of force? What type of electrostatic force are they exerting on each other? Guys? Yes. Correct, guys. Cool. It's repulsion. Yeah, it is repulsion force. Now, the distance between these two charges 10 centimeters. Distance between these two charges is 10 centimeters. Find the coefficient of limiting friction. So there is, they are in limiting equilibrium. Find the coefficient of friction between each particle. So you have to find what is mu. what is mu. So I'm giving you, okay, how long do you require, guys? I guess 2 minutes would go good. So your time starts now. So I'm going to give you 2 minutes. Please try to answer this. So hint is, use free body diagram. Draw FBD. Draw FBD and try to analyze what is the quotient. You know what is mu? What is mu? The static friction. The quotient of static friction. No, F is equals to mu times of n. If you remember, F is equals to mu into n. This we studied in our 11th standard. Okay, where F is friction and mu is coefficient of friction. You have to calculate mu here. And what is n, guys? What is value of n? What is n? N is nothing but the normal force, that is nothing but m into g. Okay. Now, yeah, your time. Try to answer this. 1 minute up. 1 minute up, guys. Try to answer this. Yes, I'm going to launch the poll. If anyone have tried and have got the answer, please reply. Hi guys. Yep. Please try to answer. Yes, guys. 2 minutes up. I hope I would be. I'm expecting you guys to answer. Please try to answer. Yes, I had started receiving answer. Oh. Yes, guys. Come on. Yes, correct. Tejas. Yes, correct. Yeah. Okay, cool, guys. Come on. So it's only 12 have answered so far. Yes, correct, Prakash. Prakash Gowda, check your answer. Tejas also check your answer. Tejas and Prakash Gowda, please check your answer again. So, guys, is it very tricky problem? Do you feel this problem is bit tricky or confusing? Churchill, this is very easy. Okay, we'll solve this. Okay, do you feel this problem is bit tricky or you didn't understand the question or something like that? Guys, please reply. You can't. Yes. Okay, cool. So, how many of you did not understand the question? Hi, guys. So, how many of you did not understand the question? Okay. Yeah. Cool. Hi, Hari Prasad. So, okay. Sorry. Yep. No, Hari Prasad. Please check your answer again. So, guys, I'm going to end the poll now. So, I received some answers. Okay, let me end the poll. Correct, Shailaja. Come on, cool. Yes. So, guys, so most of you have answered B. So, 40% answered B, 27% answered C. What's wrong? And 33% have answered D. Let's check what's the correct answer, okay? Tejas, please check your answer. Prajwal, check your answer. Okay, come on, guys. So let's draw the free body diagram, okay? So first step, okay, we'll go stepwise. Okay, I'll try to go stepwise. Correct me, yeah. Please follow the chapter. I mean, follow the steps very carefully, guys. I feel my internet connection is getting low, so I'm going to turn off my camera. Yeah, thank you. So what's given here, guys? So there are two particles of same material having mass of 5 gram. So I have one material of 5 gram. Okay, I have a material of 5 gram, and I have another material, say even that is of 5 gram. Okay, now what happens? So these two are kept on a table. Let's draw a table now. Acha, we have a table. On this table these two are kept. Okay, now these two are kept at a distance of 10 centimeters. Okay, so distance between them is 10 centimeters. Now if the distance is 10 centimeters, now we'll convert that 10 centimeters into meters. How much is 10 centimeters in meters? How many meters is it? So 10 centimeters is equal to how many meters? Guys, you guys should help me solve. Please help me solve. Yes, correct, Prajwal. Cool. Others? So 10 centimeters is nothing but 0.1 meters. Okay, 0.1 meter. Okay, I don't know why is this happening. Yeah. Yes, correct, Hari Prasad. Now what should we do? We should draw the free body diagram. We should draw the free body diagram for this. Very first step is draw free body diagram. So first step, draw free body diagram. So what happens here? Yes. So I have one material. I have another material. Both weighs 5 gram. Now since both weigh 5 gram, okay, if I draw the free body diagram, the weight is 5 into 10 power minus 3. I am converting grams to kgs, guys. 5 into 10 power minus 3 kg, and again I have 5 into 10 power minus 3 kg into what is my acceleration due to gravity into g. So this will be my mg. Other than these, so I'll be having a normal force acting upwards, right? So I'll be having some normal force. Okay, these two forces are equal, so these two cancel out each other. Okay, so we don't want these two. So what is the next thing which we require? What is the next thing we require? We have to check for, yes, these two carry a charge, right? Correct, Namrata. These two carry a charge. What is the charge on this? The charge on this is 10 power minus 7 coulomb. Charge on this is 10 power minus 7 coulomb. Okay, both carry a charge. And since they are kept on a table, they experience a friction. Say they try to tend to move in this direction, right? My material try to move in this direction with force Fe. The force is in these two directions. It's the repulsion force, and the friction force is given by F. Now, yes, the static friction, I know these two are the forces which are acting in this direction. If there is external force, the frictional force is equal to the net external force acting on the body. Okay, so what is the external force? The external force is the electrostatic force between these two materials. Now these two materials experiencing the electrostatic force is that is the amount of force which is acting on the friction. See, it's moving with some with some force Fe, right? The same amount of force will be applied at the base with the friction. Now I can equate that the friction is equals to Fe. Can I do this? Guys, can I do this? Can I do this? My frictional force will be equals to my electrostatic force. Correct? Say the only external force which is acting on these two bodies. Yes, my electrostatic force. Okay, the only force which is acting externally is my electrostatic force. See, the mass and the weight and the normal forces cancel each other since they are of same magnitude, but the only external force acting is my is my electrostatic force, and this external force will be equal to the frictional force. Always the net external force acting will be equal to the frictional force, guys. This we have learned in our 11th standard. The external force acting, the force external acting on the object gives is equals to the frictional force. Please make a note of that. So what happens in limiting condition? So they have given in limiting equilibrium condition. So in limiting condition, particles are just about to move. Limiting condition andre no. What is limiting condition? So limiting condition means the particles are just about to move. Okay. So my particles are just about to move. At that moment, whatever the condition I get is the limiting equilibrium condition. So the net external force Fe, I should find Fe. What is Fe? What is Fe, guys? So what I'll get is F limiting. What's wrong? F F limiting is equals to Fe. So I can write F limiting friction is equals to my electrostatic force Fe. Now try to equate this, guys. What is my limiting friction? I know my limiting friction F is equals to, or F limit is equals to mu times of m into g, where m into g is nothing but n. So mu mg is equals to, what is my force? Electrostatic force K Q square by R square. Okay, try to substitute the values of K, Q and R. Try to substitute the values of K, Q and R, M and G. Mu is equals to K Q square by R square mg. So if I substitute all the values, I get 9 into 10 power 9 into, what is my Q? Q is 10 power minus 7 into 10 power minus 7, 10 power minus 14 divided by, what is R? R is 0.1 whole square, yes, into 5 grams. I'll convert that into kgs. 10 power minus 3. Yes, am I correct? Yes, into my acceleration due to gravity 10. Now guys, try to simplify this. What is the number I get? What is the number I get? Yes, correct, Tejas. People at YouTube live, please try to answer. Hope you have understood this. If you have not understood, please let me know. And people here also, please let me know if you have not understood any of the steps. So first step is I have to draw the free body diagram. So when I drew the free body diagram, I found that the mass and normal force, the weight and normal force were getting cancelled, so I didn't consider them. Second thing, I was checking for any external force. The external force here was the electrostatic force. Okay, there are two electrostatic force. Now this electrostatic force, so there is some electrostatic force Fe here, one more Fe here. Now due to this Fe, there is some friction on the table. So since these two materials are having or on the table, so these two materials experience a frictional force. Now what is limiting equilibrium condition? Particles are just about to move, they did not move yet, they're just about to move. At that moment, what is the friction they get is the limiting friction. So the limiting friction F limiting is equals to Fe net external force. Okay, we'll make a point, right? We'll make a point of that. So limiting friction F limiting is equals to net external force. So net external force is my Fe. So mu mg is equals to, I know my net external force is F is equals to kq square by r square. So mu is equals to kq square by r square times mg. Okay, cross multiply. After simplifying, you get the value as 0.18. Okay, 0.18. So there is no, since this is a coefficient of friction, it's a scalar quantity, it's not, and it's not, it's having only magnitude. Okay, so it's a scalar quantity, it doesn't have any unit too. So correct answer is 0.18. Option C is the correct answer. Hope everyone have understood this, guys. If you have any doubts in any of the steps, let me know, guys. Okay, someone did not understand. Amit, may I know which step you did not understand? Guys at the YouTube live, yes, Shashwita. You raised your hand, Shashwita. Any doubt? Okay, someone raised the hand. Someone has doubt. Chandrika, please tell me which step you did not understand. Guys, please reply. Which step did you guys didn't understand? Okay, should I explain again? Do you need me to explain the steps again? Okay, yes. Okay, very first step, Chandrika. So I'm going to explain very quickly, guys. Please listen carefully. So what's happening? So I have two materials, each of mass 5 grams. Now these materials are separated by a distance 10 centimeters, and these two materials has a charge of 10 power minus 7 coulombs in them. Now when there is some charge present between two objects, what happens? There is electrostatic repulsive force existing. So this repulsive force makes these two objects to move in the opposite direction. So this moves in this direction, this moves in this direction. Okay, now I have to draw the FBD. So when I draw the FBD, I get my mass, the weight W is equals to mg and normal force to be equal. So I won't consider my mass and normal force in any calculation. Instead, I'll consider only the external force which is acting. My external force which is acting is Fe, the electrostatic force on both the charges, or sorry, both the materials. When these two are trying to move, so when these two are trying to move here, so at that point of movement, what happens? There exists some frictional force because it's touching the surface of the table, right? So the net electrostatic force will be equal to the limiting friction. Now what is limiting friction condition or limiting equilibrium condition? Particles are just about to move at this stage. So particles, when they are just about to move, at that moment, whatever the force or whatever the friction I get is the limiting friction. So F limit or limiting friction is equals to, we know any friction, F is equals to mu times of N, where N is nothing but mg. So mu times of mg. So F limiting is equals to Fe. So I know F limiting is nothing but mu times of mg Equate that to electrostatic force, that is k q square by r square. I know my value of k is 9 into 10 power 9 and my q square is 10 power minus 14 by r square is zero point 0.1 whole square into 5 into 10 power 3 into 10. Now, yes, try to solve this. Guys, simplify it and you should get the answer. Okay, did we miss something anywhere? Did we miss something anywhere? Okay, let's check. Mu is equals to 9 into 10 power 9. There is some problem with powers, right? 10 power minus 14 by. Okay, we have 0 0.1 square. 0.1 square gives me 0 0.01. Okay, there is the culprit. So 5 into 10 power minus 3 into 10 into 10 power minus 2. I think this is where we made a mistake. Okay, let's check this condition too. So I should get, so I will get 10 power minus 4 here. Okay, so 9 into 10 power 9 by 5 into 10 power minus 14 into 10 power minus 4. Okay, try to simplify this, guys. Minus 14 minus 4 plus 9 is nothing but 10 power minus 9. So 9 by 5 into 10 power minus 9. So what is 9 by 5? 9 by 5 is 1.8. What? What's that? Okay, 5. Okay, guys. So my magnitude is 0.18. I know I should check the powers. We'll check the powers, guys. We'll come to this again. So I hope you got to know how to calculate the method. I hope you guys got to know the method, how to calculate it. Okay. So I'll give you some set of homeworks for today. It will be available in your notes, guys. So I'll give you some set of questions to solve. Try to solve them. We'll discuss all of them in tomorrow's class. Okay. So I have some set of questions to you guys here. I'll check those questions now. So if you solve questions, and I'll try to give more questions after once you have solved these. Okay. Once we have solved these, these set of questions, we'll try to solve more questions. Cool, guys. Then, yeah. Hope for people at YouTube, I'll try to send you guys in your Telegram groups. So you have the Telegram groups, right? So we'll and post all the queries or all the questions in your Telegram group, so that you could check there. Okay. Cool. Yes, guys. Yeah. If anyone have any doubts, let's take up now. If anyone have any doubts, let us take up now. Yes, Prajwal. Cool. So yes, if you have any doubts, please let me know. I'll try to solve them as much as possible now. Yes, guys. Hi. So hello, YouTubers. Yes, I'm going to post all the notes and all the notes for all the links for notes and YouTube live. recorded videos would be available for all of you by end of today. So the links would be shared to you guys in your WhatsApp groups and Telegram groups by today. If you have missed any of the classes earlier and if you want to refer them, or if you want to refer something late after some time, you could refer in those materials. Yep. Okay, Anusha has said out. Sir, electric field don't pass through semiconductors. Electric field do pass through semiconductors. So there is something called as your electric devices, all the electric devices like the memory card. If you have ever owned a computer and if you try to remove the RAM card, so there is something called as RAM, random access memory. There's a small card type which is made out of semiconductors, static RAM. It's a static RAM. So this RAM chip is kept in an electrostatic shielded plate. This RAM is kept in an electrostatic shielded plate. It's because it, whenever we touch, even the touch could change even the human touch, or if even a small touch from any other thing, or if even a small spark can destroy that RAM. When a small spark can destroy that RAM, which is a semiconductor device. So that's the reason we try to keep the RAM in a safe, secured place where we don't have electric circuits or static. Even the static electricity will destroy the RAM. So we'll try to isolate that in a electrostatic shielding, just like the Faraday cage or Faraday shield. Similar to that, we have a metal tray where we keep the RAM. So why do we do that? Is because yes, electric field will pass and will try to manipulate the data of the RAM. So yes, electric field will pass through the semiconductors too. Anusha, to answer your question. Yes, guys. Any other questions? Hi, guys. Okay, cool. So if there's no question, then shall we wind up? Okay, we shall wind up today. Then we'll meet tomorrow. In tomorrow's class, we'll discuss more problems. So I'll be giving you. I'll be sharing you this notes where we have some sets of problems. Try to solve these problems at your end, and we'll discuss all the problems. And also, in addition to this, I'll give you more problems to solve. Okay, these are the standard JEE mains problems, and yeah, we'll discuss them. Cool, guys. Then we'll meet tomorrow. Then till then, see you. Bye bye.